Ever pondered the mystery of how airplanes, these massive metal birds, manage to soar through the skies? This marvel of human ingenuity, as natural to us now as watching birds take flight, is a complex dance of science and engineering. At its core, the magic of flight hinges on the principles of aerodynamics, the study of how air moves around objects. But it's not just about the air, it's also about the forces acting upon our airplane, guiding it through the vast expanse of the sky. Understanding flight involves comprehending four basic principles: lift, weight, thrust, and drag. Lift propels the plane upward, while weight pulls it back to Earth. Thrust propels it forward, and drag tugs it back. These forces in a delicate and constant interplay enable the miracle of flight. So, buckle up, as we're about to embark on a fascinating journey. Today, we'll delve into these principles, and by the end, you'll grasp the magic of flight. First, let's unravel the mystery of lift, the force that gets an airplane off the ground. Lift is a fascinating concept that helps an airplane defy gravity. It's not magic, but the application of a scientific principle known as Bernoulli's principle. Named after the Swiss mathematician Daniel Bernoulli, this principle explains how fluid dynamics, including the flow of air, can create lift. Consider an airplane wing, or airfoil as it's technically called. Notice its unique shape? It's designed that way for a reason. The top of the wing is curved while the bottom is flat. When the plane starts to move, air flows over both the top and bottom of the wing. But here's the catch. The air going over the top has to travel a longer path due to the wing's curved shape. This makes the air move faster over the top than the bottom. Now, according to Bernoulli's principle, faster moving air creates lower pressure. So we have a situation where there's high pressure beneath the wing and low pressure above it. This pressure difference is what creates lift. The wing, and thus the airplane, is literally pushed up into the sky by the higher pressure from below. With this understanding, we can appreciate how a massive metal object like an airplane can gracefully soar above the clouds. So, lift is what propels the airplane up into the sky, but what keeps it from floating away? We'll delve into that in the next scene. Stay tuned. Weight, the force of gravity pulling downwards, keeps the airplane from floating off into space. It is the invisible hand that constantly tugs at everything on board: the aircraft, the fuel, the passengers, and their luggage. This force counters the lift, the upward push that keeps the plane airborne. Picture this: an airplane is like a seesaw, with weight on one end and lift on the other. The challenge is to keep the seesaw balanced. Too much weight, and the plane struggles to take off. Too little and it risks ascending too rapidly, which can be just as dangerous. The key is maintaining a delicate equilibrium. Pilots, with the aid of modern technology, constantly monitor and adjust to keep the seesaw level. They manage the weight by controlling fuel consumption and distributing the load evenly. This balance is not just about keeping the plane in the air, but it's also about ensuring a smooth and safe ride for everyone on board. Now that we've got our airplane up in the air and not floating away, how do we move it forward? Enter thrust, the force that propels the airplane forward. The world of aviation is nothing short of fascinating, and thrust plays a pivotal role in this grand spectacle. It's the power that pushes our aircraft into the great yonder, against the pull of gravity and the resistance of drag. Now you might be wondering, how do airplane engines work to create this thrust? Well, it's all about pushing air. Yes, you heard right, air. Whether we're talking about propellers or jet engines, the principle remains the same. These wondrous machines suck in air, compress it, mix it with fuel, and then ignite it. This combustion process results in a forceful expulsion of hot gases out the back. This leads us to an interesting law of physics, Newton's third law, which states that for every action there's an equal and opposite reaction. So when our engines push air backwards with great force, an equal force pushes our airplane forward. It's this continuous push and pull, this tussle with the air, that keeps our airplane soaring through the sky. But it's not just about the mechanics of engines or the laws of physics. It's about the spirit of human ingenuity, the audacity to dream, and the relentless pursuit of making those dreams a reality. And that's what thrust is all about. Thrust gives us forward motion, but what might slow us down? Well, stay tuned to delve into the world of drag, the force that resists our airplane's forward motion. Our final force to understand is drag, the resistance an airplane faces when moving through the air. To get the full picture, we need to consider two types of drag: parasite and induced. Imagine you're an airplane soaring through the sky. While you're enjoying the view, you're also fighting a constant battle against forces that want to slow you down. That's parasite drag. It's a combination of all the forces that work against the forward motion of the plane. Think of it like trying to run through a crowd. The more people there are, the harder you have to push to get through. In the world of aviation, those people are air molecules. The faster you go, the more air molecules you meet, and the more resistance they create. But then, there's also friction. As the airplane moves, it rubs against the air, creating friction, which contributes to parasite drag. It's like trying to slide your hand across a rough surface. The rougher the surface, the more friction there is. That's why airplanes are designed with smooth surfaces, to reduce this friction as much as possible. Now let's talk about the second type of drag, induced drag. This one's a bit more complicated. You see, when an airplane creates lift, it also creates induced drag. It's like the other side of the coin. When the wings push air down to lift the airplane up, it creates vortices, or mini tornadoes at the wingtips. These vortices create turbulence, which works against the forward motion of the airplane, creating induced drag. So, you see, drag isn't just one thing, it's a complex interplay of forces that work against the airplane. But it's not all bad. Without drag, airplanes would have trouble slowing down or landing. So, while it may seem like a nuisance, drag is a necessary part of flight. By managing these four forces, lift, weight, thrust, and drag, pilots master the skies and the mystery of flight unravels.